Hello again. In this short lecture, we're going to examine like functions and quickly discuss why they're useful. Let's begin. So, like functions are equivalent functions to the empty, zero, ones, and full, where we don't need to specify a shape or type for the array we're generating. Instead, we need to provide another array, and the function will automatically take its shape and type when creating the output. Let's get a better idea of how this works. We start by defining a 2D ND array called matrix A, which will hold some numeric values. For the purpose of our exercise, as long as it's a 3x5 array, it doesn't really matter exactly what values we put into it, so we can go wild here. Just remember to print out the array afterwards to make sure it's properly defined. All right, now we're going to use empty-like to create an empty array with the same shape and type as matrix A. Once again, we begin by defining a variable with an appropriate name and setting it equal to the name of the function, np.empty-like. Unlike npEmpty, we don't specify the shape argument, but pass matrix A as an input. As we explained earlier, the function will return an array with the same shape as matrix A. As always, we call the newly created array on the next line, and we're ready to run the cell. The output here can vary, since we're using an equivalent of the empty function. So don't worry if what you're getting on your screen differs from what we have on ours. However, the shape should always be 3x5, regardless of the elements inside. Fantastic! Since all the like functions work the exact same way, we'll only go over zeros like before moving on. That said, just copy the code we wrote into a new cell and change the name of the variable and function accordingly. Once you're done, just run the cell. The output should be a 3x5 matrix full of zeros, since the input array, matrix A, had the same shape. And regardless of how many times we execute the cell, it will always be full of zeros, unlike the empty like. What is the application of zeros like in analysis? We can use this array of zeros as a starting point for a planner where we keep track of how many times we've increased or decreased a certain element of an array. Additionally, we can use it as a form of switch, where we change values from 0 to 1 and back, depending on whether elements in certain positions are relevant to us or not. The general gist of like functions is to create a second array in which we store a value for each element of the original one. This can be very convenient when working with huge databases, since we can create equivalent 0-1 arrays and go through them much faster instead of loading up the entire datasets. Since np1s like and np-full like work the exact same way, we're leaving them as an exercise and directly moving on to generating non-random sequences of data. In the next lecture, we'll explore NumPy's arange function and use it to construct arrays of consecutive values. Thanks for watching.